The next topic, inverse trigonometric functions. Inverse trigonometric functions. So what is that? For example, look at the function f of x equals sine of x. So just the first trigonometric function, sine. And then, what is the inverse of this? In fact, the inverse of this function can be denoted like this. Typically, the argument of the inverse function is denoted by y, because the given function takes x to y, and the inverse function takes y to x. So that's the common notation. Now, this function is denoted sine inverse of y. And this is sine of x, so the inverse function is sine inverse of y. Also denoted by arc sine of y. Now, sine inverse or inverse sine or arc sine, it's not like 1 over. So sine inverse of y, is not 1 over sine of y. So be careful not to make this mistake. So this is not the same. Like, for example, 5 to the power negative 1 is the same as 1 over 5, but with functions it's not so. Sine inverse means inverse function with respect to the sine function, but it's not 1 over sine, it's a different thing. And this inverse function only exists for certain x values. It's like with the function x squared, we will restrict the function f of x is sine x to x being only between negative pi over 2 and pi over 2. And now with this restriction, so here is the definition of the inverse sine function. So sine of x equals y if and only if sine inverse of y equals x. And what it means that inverse sine is undoing the operation of sine. Like sine takes x into y, and sine inverse takes y into x. So it is undoing the operation done by sine. For example, let's say that sine of pi over 6, which is sine of 30 degrees, which is equal to 1/2. But in calculus, we never use degrees, we always use radians. So pi over 6 radians, sine of this angle of pi over 6 radians equals 1/2. And this means, and this pi over 6 belongs in this interval between negative pi over 2 and pi over 2. So, sine inverse of 1/2 equals pi over 6. So it is undoing the operation of sine. Again, it works so because pi over 6 belongs in the interval negative pi over 2 to pi over 2. So here's an example of how to calculate inverse sine and how inverse sine can be combined with other trigonometric functions. Here's an example. Find tangent of arc sine of 1/7. And find it precisely. Of course, you you can do it on the calculator. Calculator typically has functions for tangent, for sine, cosine, tangent, and also for inverse sine, inverse cosine, inverse tangent. But calculator will not find it precisely, so the question is to find this precisely. And here is how you can do this. You can actually use some formulas from trigonometry, but using formulas from trigonometry is difficult, so it's much easier to use the following method. So let's denote arc sine 1/3 by alpha. So let alpha equal arc sine of 1/3. Now what does that mean? It means that alpha is a shortened angle whose sine equals 1/3. So sine of alpha would equal 1/3. And what does that mean? It means that alpha is an angle in a certain right triangle. So let's draw this right triangle. So triangle with the right angle. Another angle of this triangle is alpha, and we know that sine of alpha equals 1/3. On the other side, sine of an angle in a right triangle equals, on the other side, sine of any angle equals the opposite leg over the hypotenuse. So sine alpha equals opposite over the hypotenuse. So this is the opposite leg, this is the adjacent leg. So I remind you, sine of an angle equals opposite leg over hypotenuse, cosine of an angle equals adjacent leg over the hypotenuse. And now we know that sine equals 1/3 and also sine equals opposite over the hypotenuse. Then why don't we say that opposite leg equals exactly 1 and hypotenuse equals exactly 3? So what it means, it's the same thing. So 1/3 equals opposite leg over the hypotenuse. And the easiest way to make it work is to say that opposite equals 1 and hypotenuse equals 3. So opposite equals 1, hypotenuse equals 3. So what it means that the opposite leg in this triangle equals 1 and the hypotenuse equals 3. And what? Now let's calculate the adjacent angle. By the Pythagorean theorem we know that opposite squared plus adjacent squared equals hypotenuse squared. That's the Pythagorean theorem. So what we know from here is opposite is 1, so 1 squared plus adjacent is still unknown, equals 3 squared, which is 9. So from here we can tell that a squared, adjacent leg squared, equals 9 minus 1, which is 8. And so adjacent leg itself equals square root of that. Square root of 8, it must be positive because all the legs are positive. So square root of 8 is equal to 2 square root of 2. So it's a 2 square root of 2. So we have found the adjacent leg. Now why do we need that? Because the question is actually to find tangent of alpha, because this whole thing is alpha, so the question is to find tangent of alpha. Question is tangent of alpha, and I remind you that tangent of an angle equals opposite leg divided by the adjacent leg. But now we know they're both. Opposite leg equals 1, adjacent leg equals 2 square root of 2. So it will be 1 over 2 square root of 2. Therefore it equals tangent alpha, therefore it's exactly what the problem requires us to find. So therefore the answer is 1 over 2 square root of 2. Now sometimes some tests or homework assignments require you to actually simplify the denominator, to rationalize the denominator, in which case you want to multiply both sides, both numerator and denominator times square root of 2, so it will end up square root of 2 divided by 2 times 2, which is square root of 2 over 4. So this is how we calculate tangent of arc sine of 1/3.